So we've spent some time talking about trigonometry in a right angle triangle, but what happens if we find ourselves in a triangle where none of the angles are right angles? What can we compute? What can we determine from other pieces of information? And we actually can in certain circumstances. And there are two laws that I want to share with you today. One is called the law of sines and one's called the law of cosines. We're actually going to begin with the law of cosines. Now, before I write down the law of cosines, I want to take a look at how I've labeled this triangle. I've used lowercase a, b, and c to mean the length of this side, and this side, respectively. And I've used capital A, B, and C to talk about the angles. Specifically, we're talking about the measure of the angles when I write the law of cosines and the law of sines. So the measure of the angles you can use in degrees or in radians. I'm going to stick with degrees today. And also notice that across from side A, side lowercase a, I have angle, capital A. Across from angle C, I have side length C. And across from angle B, I have side length B. So you can put the capital A, capital B, and capital C wherever you want. You can put the lowercase a, lowercase b, lowercase c wherever you want, as long as every side length is opposite to the angle with the same name, one in the uppercase, one in the lowercase. We use lowercase to mean lengths and uppercase to mean angles. So let me go ahead now and write the law of cosines. The law of cosines starts off looking a lot like the Pythagorean theorem. C squared equals a squared plus b squared. So far that's the Pythagorean theorem. Here's where it differs. Minus 2ab cosine C. So again, you can see that the lowercase a, b, and c refer to side lengths, and the uppercase c refers to angles. Now I happen to write this as if I was solving for this side length right here. But you could change the order, the roles of any of these things. If you want to have a squared over here, you'll have b squared plus c squared over here minus 2bc cosine a. You can write it however you want. I'm going to write it like this today. So let's go ahead and do a problem. Let's say I have a triangle with none of the angles necessarily right, and this has length 4 units, and this has length 5 units. If you want to actually put units on here, we can. I'm going to do this without units right now. And we'll say that this is 30 degrees. So I know that this side length is 4, I'm told that this side length is 5, and I'm told that this angle right here is 30 degrees. So let me put in my C and my A and my B. We're not going to need angles A and B right now. And the goal here is going to be to find the length, which I'll just denote C right now, find C. So this is A and this is B. So I've given the length of two sides. I've given the angle between them. It makes sense that if I give you the length of two sides and the angle between them, there's really only one triangle you could draw, so we ought to be able to determine the length of that third side. Let's go ahead and just write out the law of sines, putting in the numbers that we know. So c squared equals a squared, which in this case, oops, is down here. That's 5 squared plus 4 squared minus 2 times 5 times 4 cosine, and I'm going to put the angle in that I know, 30 degrees. C 30 degrees. At this point, you could just go ahead and use your calculator if you want. I'm going to do the arithmetic sort of by hand for now, as long as I can. That's just my personal taste. Don't feel constrained by that. So 25 plus 16 minus 20 times 2 is 40. Cosine of 30 happens to be root 3 over 2. You don't have to know that. You can use your calculator. Make sure that when you plug this into your calculator, since I have this in degrees, make sure your calculator is in degrees. So 25 plus 16, that's 41, minus 40 divided by 2 is 20 times root 3. So c squared is equal to 41 minus 20 root 3, so c is equal to the square root of that. 41 minus 20 root 3. Now, that's about as far as we can get without a calculator. If you plug that into your calculator, you're going to get a side length of about 2.52, which I think seems reasonable. If this side has length 5 and this side has length 4, somewhere around 2.5 looks about right for that side. So in this case, we used the law of cosines to figure out the side length when we knew two other side lengths and the angle between them. And again, if it's a right angle triangle and you want to figure out the third side, you can just use the Pythagorean theorem, but none of the angles here were right angles. Let me give you another problem to show you another application of the law of cosines. Here we used it to work out, again, a side length. Let me draw another triangle. And this time I'm going to give you 3 side lengths. I'll say this has length 5, and this has length 4, and this has length 7. And what I want you to find is the angle this time, which I'll call theta. The measure of that angle I'll call theta. So this is going to be my capital C. This will be my capital A, my capital B. You can put the letters wherever you want, as long as once you decide on where the A, B, and C go for angles, you make the same decision. Opposite to A, this is little a. Opposite to B, this is little b. And opposite to C, this is little c. So last time we used it to find the length of a side. This time we know the length of the side, but we can go ahead and use it to find an angle. We just have different pieces of information, and you know that when you have everything except one piece of information in an equation, you can solve for that last piece of information. So let's go ahead and plug in what we know and solve for what we don't know. So c squared, so 4 squared equals a squared, which is, down here, 7 squared, plus b squared, which is 5 squared, minus 2 times 7 times 5 times cosine of that angle C, which in this case I just called theta. So we want to get theta by itself. We want to figure out what theta is. So again, I'm going to do the arithmetic by hand. You can plug it all into your calculator. I'm totally fine with that. So 16 equals 7 squared, that's 49, plus 5 squared, 49 plus 25 is 74, minus 14 times 5 is 70, cosine theta. So I'm going to subtract 74 from both sides. So what is that? 58 minus 58 equals minus 70 cosine theta. And I can divide both sides by minus 70. So cos theta equals minus 58 over minus 70, or 58 over 70. And I know I could reduce that farther, but let's just go ahead and use our calculator to get a decimal value for that. I get about 0.829. So cos theta equals about 0.829. How do I get theta by itself? Well, remember from last week we learned the inverse trig functions. If cos theta equals 0.829, that's the same thing as saying that theta equals the inverse cosine, which I called arc cos of 0.829. Saying that cos theta is equal to 0.829 is the same as saying that theta by itself is the inverse of 0.829. Just like saying that, let's say, x squared is equal to 4 is like saying that x is equal to the square root of 4. It's the same thing. So what we want to do is get the x by itself. we take the inverse function, and we know that we have to restrict the domain for x squared to make it to have an inverse function. But in this case, we're worried about restricting the domain. We've already done all that work. So the arc cos of 0.829 is approximately equal to 34 degrees. And again, when you take arc cos with your calculator, if you want your answer in degrees, make sure that your calculator is set in degrees. If you want your answer in radians, make sure that your calculator is set in radians. So if we know this side, this angle, and this side, you can work out the third side. But if you know all three sides, you can work out one of the angles. That is the law of cosines. Let's take a look at the law of sines now. So here's one way of writing the law of sines. A over sine capital A equals B over sine capital B equals C over sine capital C. And you use the law of sines or the law of cosines depending on which pieces of information you have and which pieces of information you need. Let's take a look at an example where the law of sines would be of use. So again, capital A and capital B and capital C stand for the measure of this angle and this angle and this angle, respectively. So let's say I give you a triangle, not necessarily a right angle. I tell you that this angle is 30 degrees, and let's say I tell you that this angle is 50 degrees. So obviously my picture is not quite to scale. And let's say I know the length of this side is 7. The length opposite to here is 7. And let's say I want to know the length opposite to that one. I'll call that x. So this is on my picture, if I make correspondence, this is my C, this is my capital C, this is, what did I write over here? This is B, and this is my lowercase b. So what we need, we know the stuff with the C's, and we want to know one of the things with the B's. So I can ignore this altogether. I'm just going to pay attention to the B's and the C's. So my lowercase b is x over sine of b over sine of 50 degrees equals my lowercase c, which is 7, over sine of 30 degrees. And what I'm looking for, I forgot to write it down, is to find x. Well, after this, it's basically just arithmetic. So x over sine of 50 degrees is not an easy thing to compute in your head. It's about 0.766. You can use your calculator to do that. Again, make sure your calculator is set in degrees, since I have written these in terms of degrees, equals 7 over sine of 30. For those of you that have had trigonometry before, you might remember that sine of 30 is 1/2 or 0.5. And to get x by itself, I'm just going to multiply both sides by 0.766. So x equals 7 divided by 0.5, which is 14, times 0.766. And this works out to approximately 10.724. So if you know, let's say, two angles, and you know one of the sides opposite to those, and you want to find the other side opposite to those angles, use the law of sines. You could also use the law of sines if I knew both of these sides. I knew one angle and I wanted to figure out the other angle. You could also use the law of sines. So the law of sines, it's clear why it's called the law of sines, right? It has sines in there, and the law of cosines has a cosine in it. Depending on what information you need in a non-right angle triangle, depending on what information you have, you can use the law of sines or the law of cosines.